Hey everyone! Let's take a look at how to take the limit of a function of more than one variable. Well, for the limit to exist, you have to approach the same value no matter which path you take, right? And if this was just a one variable and we were coming along, let's say, it's the line, the x-axis, we had x approaches something, well then you would just check the right hand and left hand limit. And if they're equal, then your limit exists. But in 3 dimensions, there's actually an infinite amount of ways to approach that point. So how do you show that the limit actually exists? Well, if we find 2 ways, if we find 2 paths that the limit is different, well, that would show the limit doesn't exist. So let's take a look at this right here. We have the limit as xy approaches 0, 0 of y squared times sine squared of x over x to the 4th plus y to the 4th. Now a good technique would be to fix one of your variables. Let's let x be 0, right? Then we're coming along basically the y-axis, right? If x is always 0. Okay. Well, if x is 0, then what do we have? Then we have just the limit. Instead of xy, we just have y approaches 0. Of what? Well, x is 0. So sine squared of 0 is 0 times something. Well, that's going to be 0. That's going to be 0 over what? Well, x to the 4th. Again, x is 0. So this is 0 plus y to the 4th. So we just have the limit as y approaches 0 of 0 over y to the 4th. Well, again, a limit means you're getting really, really close to 0. But you're never actually getting there. You never actually equal 0. So this is 0 over something really close to 0. But it's not 0 over 0. Back before, if we plugged in 0, 0 to this, we would have gotten 0 over 0. And that's an indeterminate form. That's something that requires more work. But now we have 0 over something that's not 0, and that equals 0. Okay? So we found the limit to be 0 along one path. So now let's try a different path and see if we get 0 again. If we do, well then we don't know anything. But if we get something different, then that would show that the limit doesn't exist. Okay? Well, how about we let x equal y? Well, then what happens? If we let x equal y, then we just get the limit as x approaches 0 of what? Well, again, x is y. So y squared is the same thing as x squared. So we get x squared times sine squared of x over what? Well, x to the 4th plus y to the 4th. But again, we're letting x be y, so y to the 4th is the same as x to the 4th. So we have x to the 4th plus x to the 4th, or 2x to the 4th. Okay, well that equals what? We can simplify here. We have x squared on top. We have an x to the 4th on the bottom. So the x squared is going to be gone, and this is equal to, again, the limit as x approaches 0 of just sine squared of x over 2x squared, right? 2x, because the x squared is going to cancel here into 2 of them here, so we're just left with an x squared on the bottom. Okay? Well, what do we get? If we plug in 0 now, we get sine squared of 0, which is 0, over 2x squared. Well, 0 squared is 0 times 2, which is 0. Okay, now we got 0 over 0. Well, we did not get 0, okay? We got this indeterminate form 0 over 0. And whenever we have an indeterminate form, and we're taking a limit, now with just one variable, we can apply L'Hopital's rule. And what does L'Hopital's rule say? It says just take the derivative of the top and then divide it by the derivative of the bottom. No quotient rule, just derivative of the top over derivative of the bottom, and the limit as you approach that same value will be equal to that limit. Okay, so let's try this. Let's take the limit as x approaches 0 of the derivative of the top. The derivative of sine squared x. Now again, sine squared is like sine of x all squared. That's what that means. Okay, right? Sine of x all squared. So this is like a chain rule. So this is like blop squared. The derivative of blop squared is 2 times the blop times the derivative of the blop. So that's 2 sine of x. Then the derivative of sine of x is cosine of x. So that's 2. So this equals 2 sine of x times cosine of x. Okay. And what's the derivative of the bottom? Derivative of 2x squared is, you bring down to 2, that's 4x to the 1. So that's just 4x. Okay. Well, now, if we let x be 0, what do we get? Again, sine of 0 is 0. So cosine of 0 is 1, but that's 0 times 1 times 2, which is, again, going to be 0 over 4 times 0 is 0. Okay? We got 0 over 0 yet again, but we can use L'Hopital's rule again. And what do we get this time? So this equals the limit as x approaches 0 of, okay, again, we got this indeterminate form yet again, 0 over 0. So we can apply L'Hopital's rule again to now this. Okay. Well, now we're going to have what? Well, actually, before we do that, we can probably clean this up, right? Because we have a 2 here, and the 2's going to cancel here, so this is going to equal sine of x, cosine of x. Oh, wait a minute. You know what? A better way to look at that would be to realize that 2 sine of x cosine of x is actually the same thing as sine of 2x. Right? That's an identity that, if you don't remember, you could always look up. But 2 sine of x cosine of x is the same as sine of 2x. So this is actually sine of 2x over 4x. Okay. Well, what do you get there? If you plug in 0, we still get 0 over 0. This is still 0 over 0. But now we can apply L'Hopital's rule to this, which might be easier than this. So what's the derivative of the top here? What's the derivative of sine of 2x? Well, that's the same thing as sine of blop. Derivative of sine of blop is what? Is cosine. Is cosine of blop, but then times the derivative of the blop. So times a 2. So that would be, this equals 2. Derivative of sine is cosine. So cosine of blop, and your blop here is 2x. So that's 2 cosine of 2x over the derivative of the bottom is just a 4. Oh, well now we have a constant on the bottom. So what's this? What do you get when you take the limit as x approaches 0 of 2 cosine of 2x over 4? Well, 2 times 0 is 0, but cosine of 0 is 1. Cosine of 0 is 1, so that's 2 times 1, which is 2. So this is 2 over 4, right? The limit as x approaches 0, you plug in 0, that's 2 times 0 is 0, cosine of 0 is 1, 2 times 1 is 2, and you get 2 over, you just have a constant on the bottom, that's 2 over 4, which is 2 over 4, which is 1/2. So we got the limit to be 1/2 here along y equals x, but the limit to be 0 along x equals 0. So therefore, the limit does not exist. We approach 2 different values, and we can say the limit does not exist.